Hi everyone, welcome back. Today we are going to do MCQs from covariance and correlation. First I will give you a small recap, then we will do the exercise. Okay, now in inferential statistics, if you want to know the relationship between two variables, one is bedroom and another is price. In a location you want to know the price of any flat, but you want to know how they are related to bedrooms. If I increase my bedroom from 2 to 3 to 4, then whether the price will also increase or it will decrease or it will remain same. So what is the relationship between this? That can be calculated by two methods. One is covariance and another is correlation. Okay. Now what is the difference between these two? Covariance tells you whether they are related or not. It will tell you that it is positively related or negatively related or not related at all. But correlation will take you one step ahead. It will tell you how strongly they are related. Maybe for changing a little bit in bedroom from 2 to 3, maybe there is not much difference. Okay, or maybe for changing one bedroom there is a high increase in difference. Anything can happen. That will be told by correlation only. Covariance only tell you that it is increasing. Okay, but correlation will tell you that it is increasing in a greater rate or in a lesser rate. Okay, so you understand that correlation tells you how strongly they are related. Okay, now let's do the MCQs. What does a positive covariance? Positive covariance, from the name you can understand, between two variables. As one increases, the other decreases. No, positive means if one increases, then other will also increase. If bedroom increases, price will also increase. If you study for more number of hours, your result will be good. Okay, your marks will be increased. So if one increases, the other also increases. Fine. What is the range of correlation coefficient? The range of correlation coefficient is -1 to 1. -1 means highly negatively correlated. Right? Correlation tells you how strongly they are connected. -1 completely negatively correlated. -0.8 also kind of strong. -0.5, -0.3 then negatively correlated but not strongly. Okay, you understand the difference. Same way, if it is +1, positively correlated, highly positively correlated. If it is 0.5, then positively correlated but kind of neutral. But if it is 0.2, then positively correlated but very weak. Okay, you understand what is the difference between coefficient and correlation. Okay, now what is the main difference between covariance and correlation? Covariance standardized, nothing like that. Fixed scale, nothing like that. Correlation is standardized covariance, exactly. So what is the formula for correlation? Correlation formula is covariance divided by standard deviation of one variable, standard deviation of another variable. Okay, so we can say standardized covariance means this is correlation. This is the formula. Okay. Now what does a correlation coefficient of -0.85? Just now we have discussed. You can see minus means negative. Now see 0.85. So we can say this is strongly negative. Okay. If the covariance between x and y is 0, which of the following is true? 0 means no relationship. No, not related, they are neutral, right? Which of the following values represent strongest? See, -9.90, yeah, kind of strongest because it is near to 1. If it is near to 1, then it is positively. If it is near to -1, then it is negatively. But they are strongest. 0.75, 0.60, 0.40. Strongest is this one. Okay, you have to compare with others. If all the data points lie perfectly on a straight upward sloping line, see, like this. If it is bedroom, and it is price, and this is straight upward sloping line. So here 2 bedroom, 3 bedroom, 4 bedroom. See, this is the price, maybe 1 lakh, here 2, here 3. So you can understand as it is increasing, it is also increasing. So you can easily say they are very much correlated and they are strongly correlated. So we can say this is 1. Okay. Positively strongly correlated. In which of the following cases is covariance most difficult to interpret? Okay, see, covariance is difficult to interpret when units of measurements are different. What happens to the correlation if you multiply all values of x and y by positive constant, see, it will stay same because for correlation it is covariance divided by sigma x into sigma y. So now what you are doing all values of x and all values of y. So these values are just added by some positive constant. So does it really matter to the correlation? No, because you are adding with some positive constant, right? See that here there is no unitless. That is the main difference between covariance and correlation. Covariance has unit, correlation doesn't have unitless. Okay, that is also one advantage of correlation. Now, given two data sets, this is x, this is y. What can you say about covariance between x and y? See, 1, 2, 3, 4, 5. Just plot if you have confusion. 1, 2, 3, 4, 5. Okay, but why 5, 4, 3, 2, 1? See, 1, 2, 3, 4, 5. But for x1, y5. So x1, y5 like this. x2, y4. x2, y4. This. 3, 3 here. x4, y2. So x4 but y2. So here. x5, y1. So x5 but y1. So see, this way it is decreasing. So we can say it is negative. Okay. Now covariance unit, suppose the units of x are in kilogram, y are in meter. So what will be the unit? A kilogram meter. Okay. That is the problem of covariance. It is okay. Covariance has units. Now two variables x and y have the following values. What is the sample covariance? They are telling you to calculate covariance. Okay. So let's learn what is covariance. See, the formula of covariance is 1 by n minus 1 summation of I equal to 1 to n xi minus x bar into yi minus y bar. Okay. Okay, now let's calculate this. So x and y. X 2, 4, 6, 8. Y 5, 10, 15, 20. Okay, so y is 5, 10, 15, 20. Now see the formula. You have to calculate x bar, y bar. So I can write x bar, y bar. X bar means the mean value of x. 2 plus 4 plus 6 plus 8. So 6, 12, 20 divided by 4. So this is 5. So let's write this as 5. Now 5, 10, 15, 30, 50 divided by 4. So it will be 5, 10, 15, 30 divided by 4. 12.5. So let's write 12.5, 12.5, 12.5. Okay. Now we have to calculate xi minus x bar. Okay. And yi minus y bar. So for xi minus x bar, xi means every value of x. 2. So 2 minus 5. So it will be minus 3. 4 minus 5 minus 1. 6 minus 5 1. 8 minus 5 3. For yi minus y bar, so this value and this value. 5 minus 12.5. So it will be minus 7.5. 10 12.5 minus 2.5. 15 12.5. So it is 2.5. 20 12.5. So this is 7.5. Fine. Now you have to multiply them. So xi minus x bar into yi minus y bar. See, minus 3 into minus 7.5. So it will be 22.5. This will be 2.5. 1 into 2.5 same 2.5. 3 into 7.5 22.5. Fine. Now we have to put the formula. So 1 divided by n minus 1. Here n minus 1 means total we have 4. So 4 minus 1 equals to 3. Okay, so we can write covariance of x comma y equals to 1 divided by n minus 1. See the formula once again. This is the formula 1 divided by n minus 1 into whatever our value is. So here we have to add all the numbers. 22.5 plus 22.5, 44, 45 plus 5. So this is 50, right? So now we can write 50 divided by 3. So whatever, 16.66, 16.67. Okay. Okay. So let's understand how we have calculated. This is the formula. We have just calculated x bar, y bar, x minus x bar, y minus y bar. We have multiplied them 1 by n minus 1. We have put the formula. Perfect. This is how you can calculate covariance. Okay. Now let's do it to calculate correlation also with same data. 2, 4, 6, 8, 5, 10, 15, 20. Now what is the formula for correlation? Correlation formula is covariance of x and y divided by sigma x into sigma y. So this one we have already calculated. This is 16.67. Now we have to calculate sigma x and sigma y. So sigma x equals to root over of 1 by n minus 1 x I minus x bar whole square. Okay, same way sigma y equals to root over of 1 by n minus 1 into yi minus y bar whole square. Calculate sigma x and sigma y. See, x, y, x bar, y bar. Same way we write 2, 4, 6, 8, 5, 10, 15, 20. X bar we know 5, y bar 12.5. Same thing, so we are not calculating. This is 12.5. Fine. Now we have to calculate xi minus x bar. So xi minus x bar whole square. Okay, so whatever value we have to square also. 2 minus 5 minus 3, if you square it will be 9. 4 minus 5 minus 1 square 1. 6 minus 5 1 square 1. 8 minus 5 3 square 9. Fine. Same way yi minus y bar whole square. Yi 5 minus 12.5, that is minus 7.5. So 7.5 into 7.5. You know how to multiply this kind of number. Same number, then 5, 25 will always come at the end, and 7 will be increased by 1, that is 8. So now you can multiply 8 into 7, that is 5, 6. So this is a trick by which we can calculate these types of multiplication. So whatever, it is 56.25. Okay, for this it is 6.25, 15 same 6.25, and again same 56.25. So you have to add all those numbers. 56 plus 56, 112.5. Now 6.25 and 6.25, 1250. So this is 1250. So 4, 5 to 1 to 5. Okay, so that is 1 to 5. Now 1 to 5 divided by 1 by n minus 1. So sigma x equals to root over of 1 by n minus 1 means 3 into total calculation 18, 20. So 20. Okay. And for sigma y this is root over of 1 by 3 into 125. Fine. So this is 6, root over of 6 around 2 point something, and here 40, so 6 point something. Okay, so we have got sigma x and sigma y. Now you have to put in the formula. The formula is divided by sigma x. What is the value of sigma x? 2, 6. Okay, 2 point something into 6 point something. Now you have to calculate what is correlation. Okay, clear. Now see why correlation is unitless but covariance has an unit. See, for formula covariance you have 1 by n minus 1 and this value. So if we just write the complete formula, correlation equals to covariance divided by sigma x into sigma y, right? Now, okay, so formula of covariance 1 by n minus 1 sigma I equal to 1 to n xi minus x bar, yi minus y bar. Fine. Divided by sigma x into sigma y. See, root over of 1 minus n into xi minus x bar square. Again, root over of 1 minus n, 1 by n minus 1 yi minus yi square. So if I calculate, if I multiply them, then it will become 1 by n minus 1 into root over of x minus x bar square y minus y bar square, right? So here also in numerator also we have 1 by n minus 1, here also we have 1 by n minus 1. So this will be simply removed. Okay. Here also xi minus x bar into yi minus y bar, and here also xi minus x bar square root over of that. So whatever the unit is, that is completely cut out. That is why correlation is unitless. Fine. So let's recap the whole thing. To know the relationship between two variables, we have to use any of this method, either covariance or correlation. Now covariance tells you whether they are related or not, but correlation also tells you how strongly they are related. Correlation coefficient can be from -1 to +1. +1 means highly positively correlated. -1 means highly negatively correlated. Formula for covariance is this one, and formula for correlation is bit different. So that is why in correlation the unit is removed. Okay, so that's it from these topics. So meet in our next class. Bye. Happy learning.